usual traditional podcast about quantum state. Let's start.
Normally when we think about the boundary between two things, we expect a line, like a physical fence.
Right, something you can literally point to.
Exactly. A border you can just step across.
Yeah.
Like, we expect water to turn into ice at exactly 0 degrees Celsius.
Yeah, we expect a clear, measurable threshold where, one set of rules ends and a completely different set begins.
It's comforting. But I want you to try something. If you're listening to this right now, whether you're out on a walk or sitting at your desk, commuting, whatever, just hold your hands up and look at them.
Really look at them.
Yeah, really look. Your hands are entirely made of atoms. And those atoms, every single one of them, strictly obey the completely bizarre, logic-defying rules of quantum mechanics.
At a fundamental level, the particles making up your skin and your bones, they can exist in a superposition.
Right.
They can be perfectly entangled with other particles. They smear out across probabilities.
But your hands themselves don't do that. I mean, when you look at your hand, it is in one definitive place.
Thankfully, yes, it's firmly planted in the normal classical world.
Right. You can't, use your left hand to type an email at your desk while simultaneously using that exact same hand to pour coffee in the kitchen.
That would be convenient, but no.
The quantum weirdness just stops.
Yeah.
So this is the core of it. Where is the fence? Where exactly does the quantum world end and our normal macroscopic reality begin? Is there, a size limit?
A weight limit, maybe?
Yeah.
That is perhaps the most profound, unresolved question in modern physics. Because if you look closely at the foundational mathematics of our universe, that fence you're looking for,
Yeah.
it might not actually exist. The boundary is an illusion.
And that is exactly what we are getting into today. Welcome to this deep dive. We have an incredible stack of sources from you, the listener, and it is a massive, fascinating, and I gotta warn you, deeply mathematical blend today.
It really is. We're talking theoretical physics, macroscopic quantum mechanics, the bleeding edge of quantum biology.
Oh, the biology stuff is wild.
And some truly radical, mathematically grounded hypotheses about consciousness, spiritual practices, and even the geometry of space-time itself.
It is a phenomenal stack of research. I mean, it takes us on a journey from the behavior of a few thousand sodium atoms in an ultra vacuum all the way to the holographic entanglement of the entire universe.
It's huge scale.
So our mission for this deep dive is simple, but huge. We are going to completely dismantle the assumed boundary between the quantum and classical worlds.
We're going to explore the strict mathematical limits of superposition.
We are actually going to calculate the exact decoherence time of a human being.
Yes, the actual numbers.
And we'll explore whether biological systems or even human consciousness can achieve macroscopic quantum coherence.
And we are going to get deep into the mechanics of how this works. We aren't just going to list theories.
No, we need the math.
Right, because to truly understand why the classical world is an illusion, you have to look at the equations governing the quantum one and, understand the physical tug-of-war happening right behind those variables.
Okay, so let's unpack this. I think the best place to start is with the rule book itself.
The foundation.
Right, the fundamental equation of quantum mechanics, which is the Schrodinger equation.
Yeah.
I was looking through the math in our sources, and I kept searching for the variable that acts as the speed bump.
The cutoff point.
Yeah, the variable that says, okay, this object is too big, turn off the quantum effects. But, I couldn't find it. It's not there.
It's conspicuously absent. Let's actually look at the machinery of the time-dependent Schrodinger equation.
Okay.
You don't need to be a calculus expert to understand what it's doing. On one side of the equation, you have the rate at which a quantum wave function changes over time.
Right.
And on the other side, you have something called the Hamiltonian operator acting on that wave function.
So what exactly is the Hamiltonian doing physically? In plain English?
Think of the Hamiltonian as the ultimate ledger of energy for a system. It tallies up all the kinetic energy, the movement of the particles.
Okay.
And all the potential energy, like the electromagnetic pushes and pulls between them. The equation basically says, tell me the total energy ledger of this system, and I will tell you exactly how its wave of probabilities evolves second by second.
Okay, so it's tracking energy and time. But where is the variable for mass, or the maximum allowed size?
That's the secret. There isn't one.
Wait, really?
Really?
Yeah.
Mathematically, if you have a system of n particles, the overall wave function can exist in a superposition regardless of how large n is.
So n could be anything.
Exactly. Whether n is a single electron or n is the number of atoms in an entire planet, the mathematical formalism of quantum mechanics doesn't break.
That's insane.
Formal quantum mechanics explicitly permits a planet to be in a superposition of two different orbits at the exact same time.
So if the math says my coffee cup can be in two places at once, why isn't it? I mean, before we try to put a human in a superposition, we have to look at how large physicists have actually gotten in the lab.
Right.
And it's been a pretty slow climb, hasn't it?
Very slow. Historically, we started infinitesimally small. In the 1920s, we proved electrons act like waves.
Okay.
By the 1970s, we were doing it with whole atoms. In 1999, we managed it with fullerene molecules, those buckyballs made of 60 carbon atoms.
Which are about 1 nanometer across, right?
Exactly.
Which was a huge deal at the time.
Well, it was revolutionary. And the scaling continued. By 2019, physicists successfully placed molecules composed of around 2,000 atoms into a superposition.
Wow.
But the real breakthrough highlighted in our sources is the 2026 experiment, affectionately known in the physics community as the fat Schrodinger's cat experiment.
I absolutely love that name. So what exactly did they do to this fat cat? Like, how do you put something that large in two places at once?
So they took a nanoparticle cluster made of roughly 7,000 sodium atoms.
Okay.
This object was about 8 nanometers in diameter. Now, to put it in a superposition, they didn't just split it in half physically, they fired it through an interferometer.
Walk me through the physical machinery of that. What is an interferometer actually doing to the cluster?
Imagine firing a single solid object toward a microscopic grating like a physical barrier with incredibly tiny slits in it.
Okay, got it.
In the classical world, the object either bounces off the barrier or goes straight through one slit.
Right.
But in a highly controlled quantum vacuum, the interferometer uses laser light to act as a grating.
Oh, interesting.
When the 7,000 atom cluster hits this laser grating, its wave function, its probability of existing, literally splits. The single solid cluster begins traveling along multiple physical trajectories simultaneously.
And the separation distance they achieved in this 2026 experiment is the crazy part, right?
It was staggering. The distance between the superimposed states reached 153 nanometers.
Okay, wait. So to put that in perspective, the object itself is 8 nanometers wide.
Yes.
But it's existing in two places, separated by 133 nanometers. That means this solid chunk of sodium is in two places at once, separated by a distance more than 16 times its own physical size.
Exactly. And they proved it by observing the resulting interference pattern when the paths were recombined.
How does the pattern prove it?
Well, if the particle had just taken one path or the other like a normal classical object, it would just hit the detector in a straight line.
Right. Like a bullet hitting a wall.
But an interference pattern, those zebra stripes on the detector, only happens if the object went down both paths and interfered with itself. The pattern absolutely proved the 7,000 atom cluster was literally in two places at once.
Okay, 7,000 atoms is a monumental achievement for a lab. But let's be real, it's still microscopic.
It is.
If the Schrodinger equation has no upper size limit, why is it taking us a century to go from one atom to 7,000? Like, what actually forces the superposition to collapse into a single reality?
The enemy of superposition isn't size, it's information leakage.
Information leakage.
Yes. In physics, we call this decoherence. Decoherence happens the exact moment the surrounding environment gains information about the object's physical position.
Okay.
And I want to be very clear here. It is not about a conscious human scientist looking through a microscope.
Right. It's not mystical.
The universe doesn't care if you have a PhD or eyes. It's strictly about physical interaction.
So decoherence isn't about a person looking. It's more like, well, imagine a fugitive trying to hide in a dense, quiet forest.
I like that.
Doesn't matter if the police actually see him with their own eyes. If he snaps a twig or leaves a footprint in the mud, or if his body heat warms the air around him, the forest knows he's there.
Exactly.
He has leaked information into the environment.
That is a perfect mechanical analogy. The footprint is the leaked information, and we can calculate exactly how fast that fugitive gets caught using the mathematics of vacuum decoherence.
Let's do the math.
The rate of decoherence, designated by the Greek letter gamma, is a tug of war between three variables. Gamma equals n times sigma times v.
Okay, I'm looking at these variables in the notes. Let's translate this. What are we multiplying here?
It translates perfectly to your forest analogy. The variable n is the density of particles in the environment, how densely packed the twigs and leaves are in the forest. Sigma is the interaction cross-section. Basically, The physical footprint of the fugitive, the literal area the object presents to the environment.
Right. And V.
And V is the velocity of the environmental particles flying around, how aggressively the wind is blowing the forest against him.
So the denser the gas, the bigger the object, and the faster the gas is moving, the faster the quantum state is destroyed.
Precisely.
Let's run the numbers on something macroscopic. Let's say a tiny sphere of glass, just 1 micron across. That's about the size of a single bacterium. We put it in an ultra-high vacuum chamber to eliminate the forest, so to speak.
We can try, but even in the absolute best ultra-high vacuums we can engineer on Earth, space is never truly empty.
There's always some gas left.
Right. There are still about 1 billion stray gas molecules per cubic meter, so your N is 10 to the 9th.
Good.
The cross-section, sigma, for a 1 micron sphere is roughly 3 times 10 to the negative 12 square meters.
Right.
And those stray gas molecules are zipping around at a velocity v of about 500 meters per second.
Okay, so if we calculate that, I'm assuming that means a lot of collisions.
Yeah.
How fast does the state break?
When you multiply the density, the area, and the velocity, you get a decoherence rate gamma of about 1.5 interactions per second.
Okay.
To find the coherence time, which is how long the superposition survives, you just take the inverse. 1 divided by 1.5 gives you about 0.7 seconds.
Wait, hold on. 0.7 seconds.
Yes.
You're saying that if I just pump the air out of a chamber, a bacterium-sized object could theoretically maintain a quantum superposition for almost a full second.
Mathematically, yes.
That sounds entirely doable. Why aren't we doing that every day in the lab?
It does sound doable until you factor in the ultimate, unavoidable killer of quantum states, thermal radiation.
Oh,
Because even if you perfectly remove every single molecule of gas, so there are absolutely 0 collisions, the object itself still has a temperature.
right.
And anything with a temperature vibrates, and those vibrations emit thermal photons.
The fusion is body heat. Even if he doesn't step on a twig, he's glowing in infrared.
Precisely. And the math here is brutal. We calculate this using the Stefan Boltzmann law.
Okay, how does that work?
The power radiated by an object is proportional to its surface area multiplied by its temperature raised to the 4th power.
To the 4th power.
Yes. That component temperature to the 4th power makes heat incredibly destructive to quantum states.
So if something gets even a little bit warmer, the amount of information it leaks just explodes.
Exactly. So let's look at your 1 micron sphere. If it's just sitting there at room temperature around 300 Kelvin,
Right.
you run the math, and that tiny sphere emits roughly 200 billion infrared photons every single second.
200 billion.
And remember the rule of the forest. It only takes one of those photons hitting the wall of the vacuum chamber to carry away information about the sphere's position.
1 photon snaps the twig.
Because of that thermal radiation, your coherence time drops from a leisurely 0.7 seconds down to less than a nanosecond.
Which is why every time I read about these quantum computing labs, they are totally obsessed with freezing everything.
They have to be. If you cool that same 1 micron sphere down to 10 millikelvins, which is just a microscopic fraction of a degree above absolute 0, the temperature drops by a factor of 30,000.
Okay.
But because the radiation scales with temperature to the 4th power, you don't just reduce the photons by 30,000, you reduce them by 30,000 to 4th power.
Wow.
That is roughly 8 times 10 to the 18th times less radiation.
That is a mind-bending reduction.
It completely shuts down the body heat. It brings the emission rate down to about 1 single photon every few months.
Which gives you a huge window.
Exactly. At that point, macroscopic superposition becomes mathematically and physically viable.
Okay, so temperature and speed actively destroy quantum states.
Yeah.
But that just tells us how the environment kills the superposition. It doesn't tell us when an object is allowed to act like a wave in the first place.
Right.
Is there a physical requirement for quantum behavior to show up?
There is, and it brings us to one of the most elegant equations in all of physics, the de Broglie wavelength.
Yeah.
In 1924, Louis de Broglie proposed that if light waves can act like particles, then physical particles should act like waves.
And how do we figure out the size of that wave?
The equation is beautiful in its simplicity. Wavelength equals Planck's constant divided by momentum.
And momentum is just mass times velocity.
Exactly. So the heavier an object is, or the faster it moves, the smaller and tighter its quantum wavelength becomes.
Right.
For quantum effects to become apparent in the physical world, an object's de Broglie wavelength must be stretched out enough to be comparable to its actual physical size.
So a heavy, fast object has a tiny wave buried deep inside it.
Yep.
But a light, slow object stretches its wave out into the environment.
Exactly.
Let's calculate this. What about a dust particle? A standard dust particle has a mass of about a trillionth of a kilogram.
Okay.
If it's just floating in the air at a slow 1 millimeter per second, what is its wavelength?
If you run the mass and velocity through the equation, the math gives us a wavelength of roughly 6.6 times 10 to the negative 19th meters.
Okay, help me visualize that.
To put that in perspective, that wavelength is 1,000,000,000 times smaller than a single atom inside the dust particle.
Oh, wow.
It is so tightly coiled inside the object that quantum interference with the outside world is basically impossible.
But momentum is mass times velocity. We can't easily change the mass of the dust particle, but we can change its velocity.
Right.
What if we use lasers to physically stop that dust particle, cooling it and slowing it down to almost zero, say a billionth of a meter per second?
Well, because velocity is in the denominator of the equation, as velocity shrinks towards zero, the wavelength explodes outward.
It stretches.
Yes. If you slow it to a billionth of a meter per second, the wavelength stretches out, it becomes measured in picometers, it gets dangerously close to atomic scales. The wave actually begins to breach the hull of the object.
That is incredible. Now let's go a bit smaller to a virus. A virus has a mass of about 10 to the negative 18th kilograms.
Okay.
If we slow it down in a vacuum to a millionth of a meter per second, what happens?
Its de Broglie wavelength stretches to about 0.6 nanometers.
And 0.6 nanometers is the size of actual molecules.
Yes.
Which means the quantum wave of the virus is literally the same size as the virus itself. The wave is fully exposed, which means a virus is a highly realistic candidate for a quantum superposition experiment. We could put an entire biological virus in two places at once.
We absolutely could, mathematically speaking, but I know where you want to take this.
You know I do.
You want to see the numbers for a human being.
I want to know what it takes to be a quantum superhero.
Yeah.
I want to walk through two doors at once. So an average human has a mass of about 70 kilograms.
Okay.
Let's say I'm walking through my living room at a leisurely 1 meter per second. My momentum is massive compared to a virus. What is my de Broglie wavelength?
It is 9 times 10 to the negative 36th meters.
Wow. I mean, I can't even visualize that.
You can't. It is incomprehensibly small. It's 20 orders of magnitude smaller than a single proton in your body.
That's depressing.
Your quantum wave is so infinitesimally coiled up by your massive momentum that you are solidly, unavoidably classical.
Okay, but what if I sit perfectly still? What if we account for the decoherence we talked about earlier? What does the math say about the force of my own body?
The math is violently opposed to your superhero dreams.
Let's hear it.
Let's look at the decoherence problem for a living human body. At an internal temperature of 300 Kelvin, your body is an absolute furnace.
Right.
You emit roughly 10 to the 23rd thermal photons every single second. Inside your body, there is a literal storm of biology. 10 to the 25th molecular collisions happen every second just to pump your blood, fire your neurons, and keep you alive.
So the fugitive in the forest snapping a twig. I am basically a walking, talking carpet bombing of information leakage.
Precisely. You are the loudest thing in the quantum forest. If we calculate your theoretical coherence time based on the interactions of your own biology, a human being's quantum state collapses in 10 to the negative 40th seconds.
Good Lord.
It's effectively instantaneous.
So if I want to be a quantum superhero, the math says I have to be frozen solid, near absolute zero, floating in a perfect vacuum in deep space, with absolutely zero chemical reactions happening in my brain or body.
Pretty much.
I essentially have to be dead. That's depressing. There has to be a loophole, right? If temperature and collisions destroy the state, how are physicists planning to get around this for larger objects without freezing them to death?
To find the loophole, we have to look back at the actual algebra of the information equation.
Okay.
When an object is in a superposition, we mathematically write it as state psi equals state by 1 plus state by 2, meaning the object is simultaneously at position 1 and position 2.
Simple enough.
Now, when it interacts with the environment, the state environment becomes entangled with it. We write this as state by 1 times state E1 plus state by 2 times state E2.
Okay, let's define those variables. E1 is the state the environment is in if the object is at position 1.
Yes.
And E2 is what the environment looks like if the object is at position 2.
Exactly. The golden rule of decoherence, the absolute decider of classical reality, is this. If E1 is physically different from E2, the environment has acquired information.
Right.
The universe knows where the object is, and the superposition collapses instantly. But look at the math. What happens if we can engineer a situation where E1 exactly equals E2?
Oh, if E1 equals E2, then the environment looks exactly the same, regardless of whether the object is in position 1 or position 2,
Yes.
which means no information is leaked. The universe interacted with the object, but it didn't learn anything.
This is the concept of quantum stealth, or building a quantum cocoon.
A quantum cocoon.
Yes. If you can design a system, say a microscopic organism that emits completely identical streams of photons in all directions, regardless of its internal state, the environment cannot mathematically distinguish its position.
So the environment is constantly bumping into it, but it's not gaining any usable data.
Right.
The fugitive is walking through the forest, but he's wearing boots that perfectly mimic the texture of the undisturbed dirt. His body heat is perfectly masked to match the ambient air, and he leaves no trail.
That's it, exactly. And physicists propose doing this in the lab by placing the object inside a Bose-Einstein condensate, a BEC, or submerging it in superfluid helium.
How does a superfluid hide information?
Superfluid helium has zero viscosity. It is a state of matter where all the atoms share the exact same quantum state. It acts as a frictionless information scrubbing shield.
Oh, wow.
If an object moves through a superfluid, it doesn't create classical friction, it doesn't leave a wake. The superfluid vacuum around it refuses to carry any specific position data to the outside world.
That's wild.
An object inside could maintain a superposition of, say, tens of microns because the superfluid is actively blinding the environment.
Okay, so we're getting clever. We build our ultra vacuum, we cool it down, we wrap our object in a quantum cocoon of superfluid helium. We've beaten the gas collisions, we've beaten the thermal photons, the environment is blind. We can scale this up forever, right?
You'd think so, but there is one thing we cannot block. One force we cannot build a wall against, no matter how clever the cocoon is.
What is it?
The ultimate cosmic snitch. Gravity.
Yeah, gravity destroys superpositions.
Gravity is the ultimate observer, and this brings us to one of the most brilliant pieces of theoretical work in the sources, the Penrose-D'Ossi hypothesis.
Okay.
Sir Roger Penrose and Lajos D'Ossi independently looked at superposition and realized a massive problem. If an object has mass, it warps the space-time around it. That's general relativity.
A bowling ball on a trampoline, it bends the fabric.
Exactly. But if that bowling ball is in a quantum superposition, if it is simultaneously in two places at once, then it is forcing the trampoline to bend in two completely different ways at the exact same time.
Oh, I see.
It creates a superposition in the gravitational field itself. And the mathematics of general relativity tell us that space-time violently resists being ripped into two conflicting geometries.
Space-time itself forces the universe to choose a reality. How fast does it force the collapse?
Penrose and D'Ossi derived a mathematical limit for how long space-time will tolerate this. The collapse time, tau, is approximately Planck's constant divided by Eg.
And what is Eg?
Eg is the gravitational self-energy of the difference between the two mass distributions.
Let's translate that into English. What does Eg mean practically?
The formula for Eg is roughly the gravitational constant multiplied by the mass squared divided by the distance of separation,
Okay.
basically.
Okay.
The heavier the object is and the further apart the two superpositions are, the angrier space-time gets and the faster it forces a collapse.
So let's do the math on something visible to the human eye. Let's say we have a microgram object, a tiny grain of sand.
Right.
We somehow perfectly isolate it, and we put it in a superposition separated by just 1 micron. What does the space-time math say?
If you run a microgram separated by a micron through the Penrose equation, the gravitational tension is so high that space-time forces a collapse in about 0.1 seconds.
A tenth of a second.
Sorry.
Not because a photon hit it,
Right.
not because of a gas molecule,
Yeah.
just because its own mass warped gravity too much.
Yes. Even in a perfect vacuum at absolute zero, floating in the void between galaxies, the object's own mass warps space-time enough that gravity acts as the observer.
That's crazy.
The fabric of the universe fundamentally prohibits large things from being in two places at once. This is why testing micrometer-sized objects in superposition is the absolute holy grail of physics right now. It is quite literally a tabletop test of quantum gravity.
Which is wild. But here's where the sources take a massive mind-bending pivot.
They really do.
If gravity is the ultimate destroyer of superpositions, why does space-time care so much? What if we are looking at gravity and space-time all wrong? What if space-time isn't the background stage where quantum mechanics happens, but a direct byproduct of quantum mechanics itself?
This is where we transition from quantum mechanics into quantum geometry, specifically the realm of holographic entanglement.
Okay, let's get into it.
To understand this, we have to zoom out to the largest possible scale. Imagine the entire universe, the whole cosmos, as a single closed wave function.
One giant quantum wave.
Exactly. In this view, the universe is a closed system. It doesn't have an outside environment to leak information into.
There is no forest for the universe to snap a twig in.
Therefore, the universe as a whole never decoheres. It is in a pure, eternal quantum.
But wait, when I look around my room, things are solid. They aren't in a superposition.
Because what we perceive as classical solid reality is just local cosmic decoherence.
Local decoherence.
Yes, you are a subsystem of the universe massively entangled with the air, the floor, and the light in your room. From your local perspective, the wave has collapsed. But from a God's eye view outside the universe, it's all just one shifting web of pure quantum entanglement.
Okay, so if everything is just a web of quantum entanglement, how does that create physical space? Because when I reach out and touch my microphone right now, there is physical geometric distance between my hand and the mic. How does entanglement create distance?
To understand the mechanism of distance, we have to look at something called entanglement entropy.
Okay.
For a long time, physicists assumed that if you wanted to know how much quantum information was contained in a region of space, say a cubic meter of your room, you would calculate the volume.
That makes intuitive sense.
Yeah.
Bigger box, more stuff, more information.
But the math revealed something profoundly weird. For many quantum systems, entanglement entropy doesn't scale with the volume. It scales precisely with the surface area of the boundary of that region.
Wait, it's proportional to the area? So the information inside a 3D space is actually mathematically determined by the 2D surface wrapping around it?
Yes.
That sounds exactly like, well, the physics of black holes.
Yes. You just hit on one of the greatest unifications in physics. The Bekenstein-Hawking entropy of a black hole is calculated as S equals K times C cubed times A, all divided by 4 times G times H bar.
And A is the area.
Notice the A in the numerator. It stands for area. Stephen Hawking and Jacob Bekenstein proved that all the information of everything that ever fell into a black hole isn't stored in the core. It is stored as a two-dimensional hologram on its event horizon, its surface area.
So the mathematical formula for quantum entanglement exactly matches the gravitational formula for a black hole.
It is not a coincidence. This connection was formalized in 2006 by the Ryu-Takayama formula, which is a cornerstone of the holographic principle.
What does the formula say?
Their formula states that the entanglement entropy of a quantum region equals the surface area of a minimal surface in a higher dimensional gravitational geometry divided by 4 times Newton's constant.
Okay, let me make sure I'm fully grasping the gravity of this, pun intended. You're saying that the amount of quantum entanglement between two regions of space is mathematically identical to the physical geometric surface area separating them.
That's precisely what the math proves. Entanglement and geometry are two sides of the same coin, and it leads to a staggering conclusion about the nature of distance itself. The physical distance between 2 points in space is mathematically determined by how entangled they are. The formula shows that distance scales as the negative logarithm of their correlation.
I need an analogy for this. How does entanglement equal distance?
Think about the room you're sitting in. The reason your phone is sitting 3 feet away from you isn't because there's an empty void of space between you.
Okay.
According to this math, it is 3 feet away because your particles and the phone's particles only share a specific, limited amount of entanglement. If 2 qubits are perfectly 100% entangled, they are mathematically next to each other. They occupy the same geometric point, regardless of what we perceive as physical distance.
So space is just a measure of how much two things don't know about each other.
Yes.
A lack of entanglement literally generates the illusion of distance.
That is the beautiful, terrifying essence of the ER equals EPR conjecture proposed by physicists Juan Maldacena and Leonard Susskind.
ER equals EPR.
It's a little equation. EPR stands for Einstein-Podolsky-Rosen, the 1935 paper that first defined quantum entanglement.
Right.
ER stands for Einstein-Rosen, the paper published the very same year that defined wormholes.
2 completely different papers written by Einstein describing 2 completely different phenomena.
For 80 years, we thought they were unrelated. One was about microscopic particle weirdness, the other was about macroscopic cosmic bridges. But Maldacena and Suskind's hypothesis states that ER and EPR are mathematically equivalent.
Wow.
They are the exact same phenomenon viewed at different scales.
So wormhole is just macroscopic entanglement, and entanglement is just a microscopic wormhole.
Yes. If you take 2 entangled black holes and pull them apart, The entanglement string stretching between them literally curves the background geometry into a physical bridge, a wormhole.
That is incredible.
Space-time is not a fundamental fabric. Space-time is an emergent property, a side effect of quantum information and entanglement. Gravity is just the thermodynamics of how that entanglement shifts and changes.
My brain is officially melting. So what does this all mean for biology?
That's the reason.
Because if space-time is this holographic web of quantum information constantly trying to force decoherence through gravity and thermal noise, how do complex macroscopic things like humans or animals or even single cells sustain themselves in this web without instantly decohering into random classical noise?
Right, how do we exist?
If the universe wants to crush quantum states, how is life even possible?
That is exactly where theoretical physics crashes headlong into biology. If the universe's default mechanism is to aggressively decohere things into messy classical states, then life must be a highly engineered mechanism to resist that. To understand how, we turn to the thermodynamic work of Nobel laureate Ilya Prigogine on dissipative structures.
Dissipative structures. These are systems that maintain order out of chaos, right? Like a whirlpool in a river.
Exactly. The second law of thermodynamics is the grim reaper of physics. It says entropy, or disorder, always increases over time in a closed system.
Right, a hot coffee will always cool down. A glass will shatter, but never unshatter.
But Prigogine showed that open systems like a whirlpool or a living cell can locally lower their own entropy by exporting chaos to their surrounding environment.
They act like entropy pumps.
Yes. Mathematically, the change in entropy of the biological system is less than zero, while the total entropy of the universe still increases because the system is dumping its waste heat outside. The biological system relentlessly minimizes its free energy.
So life survives by throwing its trash, its heat and entropy, outside of its own borders to keep its internal state highly ordered.
Yes. But some theorists in our sources take this thermodynamic truth a step further into a radical concept called the hypothesis of quantum evolution.
Quantum evolution.
What if biological evolution isn't just a blind process of surviving predators and finding food? What if evolution is mathematically maximizing a specific quantum function?
Okay, what's the function?
They define this function as Q equals talk times I.
Let's unpack that equation.
Yeah.
Q is the quantum effectiveness. What are the variables?
Talk is the coherence time, how long the biological system can maintain an internal quantum state without the environment snapping the twig.
Okay.
And I is the structured information within the system, its biological complexity, its DNA, its neural networks. The hypothesis proposes that evolution is the universe's algorithm for building systems that maximize both complexity and quantum coherence simultaneously.
But hold on, let me push back on this.
Go ahead.
Earlier, we ran the brutal math on a human being. We said a human decoheres in 10 to the negative 40th seconds because of body heat and molecular collisions. It's instantaneous. How can biology possibly maximize coherence if the temperature destroys it instantly?
Through intense, system-wide self-organization and phase synchronization. Let's look at the mathematics of macroscopic coherence.
Okay.
If the elements of a system are highly synchronized, the effective coherence time doesn't just depend on individual isolated atoms bouncing around, it scales collectively.
Yep.
The formula for this collective resistance to decoherence is TOF equals tau times n to the power of alpha.
Okay, let's translate that math. Tau is the base coherence time of a single isolated particle. N is the total number of particles in the system. What is the exponent alpha?
Alpha represents the degree of macroscopic self-organization. It is a mathematical measure of how perfectly synced the system is. Think of it like a rowing crew in a boat.
A rowing.
If alpha is 0, you have 8 rowers randomly splashing their oars. They fight each other, create massive thermal noise, and the boat goes nowhere. That's a random pile of sand.
Right.
But if alpha is high, all 8 rowers hit the water at the exact same millisecond. The noise cancels out, and the boat glides smoothly.
So biological life is raising its alpha to force the particles to row together.
Exactly.
Let's run the numbers on this because I need to see if this actually beats the 10 to the negative 40th seconds problem.
Huh?
Let's take a 1-gram object, a small piece of human tissue. That's about 10 to the 23rd atoms.
Okay.
Let's say the base coherence time of a single atom in that hot, wet tissue is a trillionth of a second, 10 to the negative 12 seconds.
If that tissue has 0 self-organization, if it's just a dead, random soup of chemicals, its coherence time is effectively zero. It collapses instantly.
Right.
But let's breathe life into it. Let's give it a high degree of biological self-organization. Let's set the alpha exponent to 0.2.
Okay, n is 10 to the 23rd, raised to the power of 0.2. I was looking at this in the source material earlier. It comes out to roughly 10 to the power of 4.6, which is about 40,000. So the equation says we multiply the base time 10 to the negative 12th by 40,000.
Which gives you an effective coherence time tau f of about 4 times 10 to the negative 8th second.
40 nanoseconds.
40 nanoseconds.
Wait, 40 nanoseconds for a macroscopic 1 gram object at room temperature, just through the mathematics of self-organization. That is a staggering leap compared to 10 to the negative 40th.
It is a colossal leap, and it gets better. If that biological system can surround itself with its own internal quantum cocoon, perhaps by leveraging the highly structured water inside its cells, or using resonant electromagnetic fields generated by the heart and brain to scrub the internal noise,
Yeah.
that coherence time could theoretically reach into the realm of full seconds, or even longer.
So life isn't just a random chemical accident that happened to spark in a primordial soup. Life is essentially the universe inventing a highly organized mathematical strategy to keep quantum states alive at room temperature.
That is the profound implication of quantum biology. Life is how the universe explores its own quantum nature on a macroscopic scale. We are walking, talking quantum resonators, holding back the tide of classical entropy.
Which brings us to the most radical and honestly the most controversial part of our sources.
Here we go.
If biological systems use self-organization, that alpha variable, to increase their coherence time naturally, can human beings consciously control this mathematical variable? Can we actively biohack our own quantum coherence?
The researchers in these sources suggest that we can, and more provocatively, they suggest that humans have been doing it for thousands of years under the guise of spiritual, ascetic, and meditative practices.
How?
We can entirely recontextualize these ancient practices as applied macroscopic quantum physics.
Okay, let's ground this. I need a concrete example. When a monk meditates or a yogi does deep breathing exercises, how does that map to the math of quantum self-organization?
It maps beautifully to phase synchronization. When you perform coherent breathing, say, breathing at a highly controlled rate of exactly 5 breaths per minute, your heart rate variability completely synchronizes with your respiratory cycle. It's a physiological fact.
Okay.
Mathematically, the phase of the heart rate, phi of t, aligns perfectly with phase of your breathing, phi of t.
So phi of t roughly equals phys of t. The rhythms become one. The rowers are hitting the water at the exact same time.
By conscious exertion of will, you are physically increasing the alpha of your biological system. You are increasing your degree of self-organization, drastically minimizing internal thermal noise and random molecular scattering, and therefore raising your theoretical macroscopic coherence time.
You're making your internal quantum state more robust.
Exactly.
Okay, breathing is one thing. What about the extreme practices? Like dark retreats. You hear about monks going into deep caves for weeks in total darkness, total silence, sensory deprivation.
Think back to the physicist in the lab trying to protect that 7,000 atom sodium cluster. What do?
They build a thick steel vacuum chamber, pump out the gas, shut out the light, and cool it down to isolate the system from environmental noise.
Right, to prevent the environment from gaining information. A sensory deprivation tank, or a deep dark retreat, is the human biological equivalent of the ultra vacuum chamber. By deliberately stripping away sensory input photons hitting the retina, sound waves hitting the eardrum, temperature fluctuations on the skin, you are physically minimizing your interaction with the external environment. The energy of decoherence mathematically approaches zero.
Hold on. Let me push back on this because this sounds like a massive leap. You're telling me that taking a cold shower or sitting in a dark cave doesn't just calm my nervous system or build mental resilience, but literally changes my quantum probability matrix.
Yes.
How exactly does the math justify connecting human breathwork to the Schrodinger equation? Isn't it just neurochemistry?
It is neurochemistry, but neurochemistry is fundamentally quantum mechanics at the molecular level. The math justifies the leap through the concept of h-bar effective, the effective Planck's constant for a macroscopic system.
Okay.
Let's look at the equation for macroscopic tunneling.
Quantum tunneling.
Yeah.
That's when a particle hits a solid barrier. It doesn't have the energy to cross, but because its wave function extends past the barrier, it just teleports to the other side.
Correct. The probability of macroscopic tunneling is governed by a strict exponential decay formula. The probability is proportional to e raised to a negative exponent.
Okay, what's in the exponent?
That exponent is a tug of war. In the numerator, you have the barrier, how wide it is, and how much energy it requires to cross. In the denominator, you have h bar effective, the system's effective quantum resonance.
So if the top number is huge, the probability of tunneling is essentially zero. A human body can't tunnel through a wall because we are too heavy and too uncoordinated.
Usually, yes. But if the phase synchronization of the biological organism is absolute, if the whole body is resonating as a single, perfectly coordinated quantum wave due to these extreme self-organization practices,
Right.
the effect of Planck's constant in the denominator changes. It scales up, and when the denominator grows, the negative exponent shrinks.
Which means the mathematical probability of localized quantum effects like macroscopic tunneling or neutralizing local gravitational interactions by shifting phase ceases to be strictly zero.
Exactly. The body stops behaving as a messy, decoherent collection of 10 to the 28th independent atoms and temporarily begins to behave as a single, coherent quantum object.
Wow.
This provides a theoretical physics framework for historical legends that we usually write off as mere myths. You find accounts in Tibetan Buddhism of the rainbow body, where an advanced practitioner's physical body supposedly dissolves into pure light at the time of death, or ancient, culturally ubiquitous accounts of levitation.
We usually just assume those are metaphors for enlightenment, but you're saying the math of macroscopic coherence leaves a non-zero probability that a perfectly synchronized biological system could actually alter its interaction with the physical world.
The mathematics of dissociative structures and phase synchronization leave the door open. It shifts these phenomena from physically impossible magic to highly improbable, extreme thermodynamic anomalies.
That takes the concept of mindfulness to an insane new level. It's not just being in the moment or lowering cortisol. It's actively managing your biological probability matrix.
Yes.
Which leads us perfectly into the final segment of our deep dive. The systems of quantum qualities, or SQK, and the multidimensional quantum U, MKya.
Let's get into it.
Once a human achieves this high macroscopic coherence, what happens when they interact with that holographic, entangled matrix of space-time we discussed earlier?
The sources outline rigorous mathematical frameworks for this interaction. The first framework is mind-body entanglement.
Okay.
It mathematically models human consciousness C and the physical biological body B not as separate entities, but as a coupled quantum system. The total state wave function is written as alpha times the state where C equals B plus beta times the state where C does not equal B.
Let me translate this. So the state C equals B with the alpha coefficient means the consciousness is fully identified with the physical body. It's grounded.
Yes.
And the state C does not equal B with the beta coefficient means the consciousness is somewhat separated from the physical body, acting as an independent variable.
Yes. Advanced practitioners actively balance these coefficients, alpha and beta. They use the alpha state, deep somatic grounding, feeling every cell, perfect physical breath work to stabilize the macroscopic coherence of the physical neural network. They build the battery.
Right.
Then they intentionally shift the probability weight to the beta state, perceiving themselves as an independent point of quantum awareness. This allows for phase shifts and direct interaction with the non-local entanglement networks of the universe.
Non-local networks, you mean interacting with the ER equals EPR wormholes,
Yeah.
interacting with the rest of the universe.
Exactly. And this provides the mathematical framework for hidden macroscopic entanglement. We all experience synchronicities, bizarre, highly improbable coincidences.
Like thinking of a friend right before they call, or finding an impossibly relevant book right when you need it. Carl Jung called them a causal connecting principles.
But this quantum framework models them as literal physical correlations.
How does the math model a synchronicity? How does the universe know to give you the coincidence?
It models it as a combined macroscopic wave function. Alpha times the normal state of U and the normal state of the environment, plus beta times the anomaly state of U and the anomaly state of the environment.
Okay.
In our normal daily lives, the alpha coefficient is huge. Everything is classical, boring, and normal. But the beta coefficient represents the probability amplitude of a synchronistic anomaly. Even if beta is incredibly small, mathematically, it means there is an actual physical quantum entanglement between your internal microscopic coherent state and the state of the external environment.
So when you experience a weird coincidence, it's not just a cognitive bias where your brain is looking for patterns. It's that tiny beta wave physically collapsing into your reality because your personal internal coherence temporarily resonated with an external system.
That is the premise. The universe is a single closed wave function. If you raise your internal coherence, you become a more resonant node in that universal web.
Yep.
And practitioners of these quantum biohacking techniques use a specific mathematical strategy called the Russian doll probability to maximize these interactions.
I read this part in the sources, and it is a beautiful concept. Walk us through the Russian doll.
When you focus your intent or attention on an object, you don't just perceive it in isolation, you perceive it as a nested hierarchy of entangled systems. The object is fundamentally part of a room, which is part of a city, which is part of a planet, which is part of a galaxy.
Like matryoshka dolls.
Yeah.
A system within a system within a system.
Yes. Think of it like resonant frequencies in music. If you strike a tuning fork, a piano string across the room tuned to that exact same frequency will physically start vibrating.
Right.
If the probability of a quantum resonance at each individual level of the Russian doll is pi, the total resonance probability across the entire system isn't just an average. It is calculated as 1 minus the product of all the 1 minus pi terms.
Okay, let me visualize that equation. That's 1 minus the product of all the non-probabilities. So if I actively engage my consciousness across multiple scales at once, the micro, the macro, the cosmic node, I am mathematically maximizing the total probability of triggering a localized quantum response. Because if even one of those levels resonates like the tuning fork, the total probability spikes toward 1.
Precisely. You are intentionally creating constructive quantum interference between your internal macroscopic state and the holographic entanglement network of spacetime. Which brings us to a fascinating reinterpretation of ancient symbolism.
Oh, this part is so cool.
If you look at ancient texts, you constantly see multi-armed deities.
Yeah, Hindu and Buddhist iconography. Shiva with multiple arms, or Avalokiteshvara depicted with 1,000 arms.
In the SQK theoretical framework, those aren't just mythological monsters or artistic flourishes, they are literal mathematical representations of a quantum superposition.
Wow.
Remember, a superposition is the sum of multiple probable states.
So a normal human depicted with 2 arms represents a classical focus. We interact with one single reality, one timeline at a time.
But an entity depicted with 8, 16, or 1,000 arms represents a state of immense optimized macroscopic coherence. It symbolizes a consciousness capable of maintaining multiple probability branches, multiple beta states simultaneously across the micro and macro levels of the Russian doll matrix.
They were drawing topological maps of quantum superposition thousands of years before Schrodinger ever wrote his equation. They just used the imagery of arms instead of the algebra of wave functions.
It is a breathtaking synthesis of ancient spiritual symbolism and modern quantum topology. They were describing the exact same underlying architecture of reality.
Okay, we have covered an unbelievable amount of ground today. Let's synthesize this. We started this deep dive looking for a fence between the quantum and classical worlds. We wanted to know where the weirdness stops. What we found is that the boundary isn't about physical size or mass or speed at all.
No, the boundary is an illusion created by information leakage. It is entirely about architecture, information flow, and phase synchronization.
From 7,000 sodium atoms, splitting 16 times their own width in a lab vacuum, to holographic physical distance, literally emerging from entanglement entropy to human beings using breath, cold exposure, and sensory deprivation to increase their self-organization and mathematically hack their own coherence times. The universe is inherently quantum all the way up. The classical world is just what happens when the information gets messy and leaks.
If you can control the flow of information, you control the quantum state.
So, as we wrap up, I want to hand it over to you for a final thought. We've talked extensively about biological evolution being a mechanism to maximize quantum coherence. We went from single cells up to the human brain. Where does this mathematical trajectory go next?
I want you to consider this, drawing on Prigoghine's thermodynamics and the quantum evolution hypothesis. The math suggests that the universe actively favors and selects for systems that can sustain quantum coherence at larger and larger macroscopic scales. It moved from isolated atoms to complex molecules to biological cells to incredibly complex human brains. If that mathematical trajectory is true, what comes next? Our human cities, the global internet, and our entire interconnected technological network just the embryonic stages of a planet-sized macroscopic quantum computer.
Whoa.
By linking our consciousnesses and our machines, is the Earth itself organizing into a single coherent quantum state.
A planetary wave function. We are just the neurons firing inside it. That is absolutely something to keep you awake at night.
We aren't just observing the computation, we are the computation.
To the listener who sent in these incredibly dense, challenging, and mind-expanding sources,
Thank you.
this has fundamentally shifted how I look at my own hands, my own breath, and the space between us. For everyone else, keep questioning the boundaries of reality, stay curious, and whatever you do today, try to keep your macroscopic coherence high.